Hello and welcome to Geo Topic 3.2, more about parallel lines and transversal. So in the last lesson we learned about corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles. Learned about all of those things. If you've got two parallel lines, we learned that, let's see if I can, all of the pink dots are the same. They're all the same. And all of the green dots, angled, are all the same. Because of the parallel lines, I can transfer the information about these angles down to here. Okay, so they're all the same. And then any green dot plus any pink dot is 180 degrees. So like this green dot plus this pink dot is 180 degrees. So any of those work. So it's kind of summed up here. So if the lines are parallel, then the corresponding angles are congruent. That would be like this green one and this green one. If parallel, then alternate interior angles are congruent. That'd be like this green one here and this green one. Look for the Z, remember. Alternate interior angles, look for the Z. Alternate exterior are congruent if the lines are parallel. That'd be like this pink one and this pink one. And same side interior angles are supplementary. You got the alliteration with the S's. Same side supplementary. Now, it turns out that these are actually biconditionals, which means the converse is also true. So if the corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. And if same side interior angles are supplementary, then the lines are parallel. So it works both ways. It works forwards and backwards. These statements are actually biconditionals. Congruent implies parallel, and parallel implies congruent. So with that said, you can ask yourself which lines are parallel. So we can look at the picture. Let's see here. First one I see, look at this. These green angles with these two lines and this transversal are corresponding. They're in the same position. So in this cluster and in this cluster, these are in the same position. They are congruent. So that means because the corresponding angles are congruent, P is parallel to Q. So we can say P is parallel to Q. Now, if you look at this angle and this angle, R and Q, with this transversal right here, these are same side interior angles. They're on the interior of R and Q, and they're on the same side of this blue line. So these are same side interior angles, and they add up to 180 degrees. So because these same side interior angles are adding to 180 degrees, that makes Q parallel to R. Okay, last one to look at is S and T. Okay, so let's look at this transversal. Do we know anything about that or that? Can we match up any of these angles to any of these angles? No, not really. Let me erase some of this. Ooh, magical erasable pens. Okay, can we match up this cluster with this cluster? Is anything going on there? Does any of this translate to down here? Nope. Still don't know if any of those are congruent. And the last one is, does anything in this cluster translate to this cluster? And that would also be no. There's no relationship there. So that means that S and T are not parallel. Well, they might be. We just don't know for sure. S and T are not parallel. And then there's one last thing. Parallel is transitive, actually. So that means if P is parallel to Q and Q is parallel to R, then P is parallel to R. Alright, Alright, so transitive. Parallel is a transitive word. So is perpendicular. Wait, that's not right. Perpendicular is not a transitive word. Sorry. Okay, over here, same thing. Let's see. I'm seeing in this cluster and in this cluster, this angle is the same as this angle. Those are corresponding angles, so that makes H parallel to J. Alright, now let's look at K and G. Alright, so for K and G, does this cluster translate to this cluster? Is there any information about these two? Nope. Does this cluster translate to this cluster? Well, it said that this angle is congruent to that angle. Are these two angles corresponding? No. Are these two angles alternate interior? No. Are these alternate exterior? No. So even though they're congruent, they're not one of these things up here. So K is not parallel to G. I'll just cross it out. K is not parallel to G. Okay, next. Solve for X so that the lines are parallel. So if I need these two lines to be parallel, I need these corresponding angles to be the same. I need 5x minus 20 to be equal to 90. That's what I need. If these are going to be parallel, that has to be the case. So very quickly doing your algebra here, 70 divided by 5 is 14. Now this one is the same idea, but it gets quite a bit more tricky with the algebra. Alright, so here's the deal. Here's what I'm going to do. If the lines are parallel, if these lines are parallel, then all of these pink dots would be the same. So 5y is equal to all the other ones, all the other pink y's. And all of these green dots are the same. So if these lines are parallel, this information translates to this as well. So any pink ones are the same, any green ones are the same, and any pink one plus any green one adds up to 180 degrees. So the first thing I'm going to do is look at, I've got a green here, and I've got a green here, and I've got a pink here. Okay, so a green and a pink adds to 180. That's always going to be the case. We've got a linear pair, so we've got 6x minus 5 plus 5y minus 5 will make 180 degrees. Alright. Now this is a system of, this is a problem, this is an equation that has an x and a y. If you ever get an equation that has an x and a y, you need another equation. You need two equations. If you've got two variables, you need two equations. If you've got three variables, like x, y, and z, you need three equations. Alright, so we need two equations. So we need to go back here and find another equation. How about we use these two greens are the same. So 6x minus 5 is equal to 3x plus 2y. So now I've got two equations. And there was another equation in here. You could say that these two add up to 180 as well. Yeah, I kind of like that one better. Anyway, now we're going to line these things up so we can do some elimination. So the first thing we're going to do is we got our 6x here. This is the top equation. We got a 5y. And we got this 5, we're going to bring it over here. We're going to bring this 5 over. So that's adding 5 and adding 5, which makes 190. So there's that top equation. The bottom equation we're going to do the same. We're going to take the 6x and we're going to subtract the 3. So 6 minus 3 is 3x. We got this 2y. We're going to subtract that over. And then we're going to take this 5 and we're going to bring it over to the other side. So we're going to add the 5 over. So all I'm doing is moving things around so that my x's, my y's, and my constants line up. These are called constants. Now what I'm going to do is I'm going to take the bottom equation and I'm going to multiply by 2. Because watch what happens when you multiply by 2. So 2 times 3 is 6x, 2 times negative 2 is negative 4y, and 2 times 5 is 10. So now that these are lined up and they're the same, I can eliminate using subtraction. 6 minus 6 is nothing. 5 minus negative 4 is 9. And 190 minus 10 is 180. So now if I divide the 9, I get 20. So I've solved for y. Once you solve for y, you go back and you solve for x. You can plug in x anywhere, any of these equations, you can plug x into, sorry, y. Y is 20. So for example, I could plug it in, let's use this one. We could do 6 times x plus 5 times 20, 5 times 20, because remember y is 20, plus 100 is equal to 190. So now subtract your 100, and you get 90, so 6x equals 90. And x is going to be 15, I believe. Yeah, 15. There we have it. We've got our system of equations solved for. That's a lot more tricky than this one. See, this one only had an x. This one had an x and a y. So if you can avoid the x and the y, you should. But if you can't avoid x and y in your equations, you have to do a system of equations. And I know that you did some of that in algebra. We're going to skip example 3. We're going to go down to example 4, and I'll get you started, but I would like you to try it on your own. And we just got to figure out all of these angles. Alright. So it says E is parallel to D. So we got parallel there. We got basically anything that looks parallel in this picture is parallel. Alright, that's what that's saying. Anything that looks parallel is parallel. Alright, so let's find the measure of angle 1. Now the measure of angle 1, this angle, will be the same as this angle, which is the same as this angle. Alright, and 3 is the same as this angle. Alright, these are corresponding. See how they're like the same? They're like all the same. So 1, 3, and 137 are all the same. They're corresponding. These are corresponding and these are corresponding. So that would be 137 and 137 for that one. Angle 2 is, I believe angle 2 is this angle right here. It's got to be, even though it's not as clear. Let's see, does this angle correspond with anything? This angle corresponds with this angle, which corresponds with this angle. See that? So this is the same as this, which is the same as this, so 71 for that one. Angle 4 is this angle, which corresponds with this angle, which corresponds with this angle, which is the same as this angle because they're vertical. So 43, 43, 43, 43. And the last is angle 5. Where's angle 5 at? Ah, here it is. This angle corresponds with 2. This is the same sort of angle, so 5 is also 71 as well. So it's puzzle. Next is the proofs. Alright, so here's the deal. We're going to prove that the blue line here is parallel to this blue line. Prove that those two lines are parallel. And we have some givens, so let's label our givens. Our givens are that this line is parallel to this line, and 2 is congruent to 3. That's what we have. So given this information, we need to use this to spit this out. This is our goal. Our goal is to make this statement. That's the goal. We use our givens to try to make this statement. So we're going to start with the lines of parallel. Now, if you look in the diagram here, 1 and 3, so what is 1 and 3? 1 and 3 are like these angles. Those are same side interior. 1 and 3 are now supplementary because the lines are parallel, same side interior implies supplementary. With parallel, same side interior angles are supplementary. That's my reason. That's one of the theorems that we got. Now, supplementary implies that they add to 180 degrees. That's the definition of supplementary. 2 and 3 are also given to us as congruent. And because I'm using measures, I'm going to change that to 2 is congruent to 3 to the measure of angle 2 is equal to the measure of angle 3. And now I can do some substituting. Because look here, this is 3 and this is 3. So I can replace the 3 with a 2. So that's the next step, substitution property. Take the 3 here and replace it with a 2. So now 1 and 2 add up to 180. These two angles add up to 180. And those two angles, again, are same side interior angles. Hold on, I skipped a step. Because they add to 180, they are supplementary. And they're also same side interior. So this is the converse. If same side interior angles are supplementary, then the lines have to be parallel. Same side interior angles are supplementary, then the lines are parallel. So what we did is we went from parallel to supplementary, and then we went backwards from supplementary to parallel. Parallel implies supplementary, and supplementary implies parallel. So it's like we did it and then we undid it. And that's what we learned today. We learned that the statement's true and the converse is also true. Parallel implies supplementary, supplementary implies parallel. That's what we did. Okay, next. Prove the following. Let's read our givens. It says that segment DE is the angle bisector of angle DBC. So here's BDC. So this here is a bisector. I'm going to go and label it like that. That's what bisector means. So there's my proof. That's going to go in the proof. Because this is a bisector, 3 is congruent to 4. That's going to be in here soon. They also give us that 1 is the same as 4. So 1 is the same as 4. And I can see how this proof is going. Look at this beautiful Z right here. Those are alternate interior angles. So if 1's congruent to 3 and 3 is congruent to 4, so that thing's going on there. There's the diagram. We're trying to prove that this is parallel to this. We're trying to prove that the two orange lines are parallel. So I'm going to stop the video and you're going to try that on your own.